So my talk today is How Secure Is This Thing Anyway? A guide into bug bounties and mobile security. Okay, so a little about me. I'm originally from the Bay Area, so I'm from Berkeley, California, which is not too far from San Francisco, California. And I currently reside in Charlotte, North Carolina. I've been there for the past 10 years. I work as a penetration tester with a focus on AppSec. And I've always been interested in mobile and decided to take the plunge this year, at the beginning of this year. And you can find me on Twitter at @thefluffy007. The goal of this presentation is I want everyone to become empowered to start your journey into bug bounties if you so desire. So just to give a little background on this here, I jumped in the beginning of this year and I participated in a bug bounty weekend group with HackerOne, and I had that expression the whole weekend. It was like, what did I get myself into? Why? So, but I learned a lot, and I found that with most people, they have that same expression as well. Okay, a disclaimer. So the images used in this presentation are not from actual bug bounties programs, and the reason I'm doing that disclaimer is for most of them have non-disclosure agreements, and I'm not trying to get in trouble. So that quick disclaimer. So what is a bug bounty? So a bug bounty is where you can find vulnerabilities for a specific company. For instance, here we have Credit Karma. This is from BugCrowd. So essentially what they do is they provide a short synopsis of the company. Also tell you on the right how many vulnerabilities have been rewarded. Validation is after you submit a report, the validating is to make sure that it's actually a true bug. And in this case, it takes within 4 days. And 75% of submissions are accepted or rejected within the 4-day period. And it gives you an average payout. So in this instance, the average payout was $250. And at the, yay. Okay, so here, it lists the ranges per vulnerability. So 200 to 5,000. The 5,000 will be for a more critical bug like SQL injection and similar bugs. So the types of bug bounties, you have reward and swag. So for reward, it's compensation based, based on the vulnerability and platform, and higher the severity, higher the payout. So what do I mean by that? So if you look on the right-hand side of the slide, oh, crap, sorry. I was getting too ambitious. Here, on the right side, you will notice that for APIs, iOS, and Android, a P1, which signifies a critical, you could get paid $5,000, whereas if you find it on the website, it is $3,000. So again, P1s are critical, P2s are high, P3s are medium, and P4s are low. So higher the severity, higher the payout. You will notice a P4 is $250, whereas a P1 is $5,000. Swag. So, with other companies, in lieu of giving you money, they like to give you prizes. Instance, clothes, hats, shirts, hoodies, gadgets, backpacks, and stickers. This picture here is sample swag. I'm sure anyone who has gone to a conference, you've picked up swag before from the different vendors. Okay, bug bounty stats. Here, the source of this is from HackerOne. So this is a guidance for companies that are thinking about going into the bug bounty space. So level 1 is a company that is just entering the bug bounty arena, whereas a level 5 is a company that is more mature and has gone through the bug bounty program, worked out kinks in their program, and they're more mature. You will notice that as for the criticals, the more mature the bug bounty program, the more the payout is. Okay, so to talk a little bit about mobile devices, because that is part of the talk. So, I'm sure the majority of you have a mobile device. So, you know, they're great. You can do a lot of stuff. Look at bank information, shop if you want to, browse the internet. I've noticed a couple of you have done that. I've been watching you. And browse social media. So while this is great for your device, these are the different attack vectors from Now Secure. So it's broken up into the actual device, the network, and cloud data center. So as you can see, while your device, you can do many lovely things, it's not secure. So there's many things you can do. For instance, you can do SMS phishing, text phishing, for apps, you know, sensitive data storage, intent hijacking, GPS spoofing. You know, this is the attack surface for mobile devices. So as you can see, there's a lot of ways to hack into your phones. Okay, so my talk will be on Android. I have an Android, no offense to any Apple people, but I have an Android and that's what I'm used to. So to give a little bit of background with Android devices, they are severely fragmented. What does that mean? Well, Android is open source and the fragmentation comes in where mobile providers can add custom code on top of the Android operating system for specific devices. So for instance, if I have a phone and for the sample Android window size, I don't like it. I'm like, it doesn't work for my phone, it's too big, it's too small. I can go and modify that for my specific device. So while that sounds really, really good, the problem with that is it leads to interoperability issues, meaning that you, depending on the device, you can have two devices that don't have the same code. And that comes into play when you do bug bounties because you realize, hey, while, you know, the Galaxy S8 you know, is secure, the S6 might not be, or S7. So to give a little bit about Android security, it is based on the Linux kernel. It provides the following security features, a user-based permission model, process isolation, and the ability to remove unnecessary and potentially insecure parts of the kernel. So, application sandboxing. So, how this works is you can isolate apps from each other. It assigns a unique user ID to each Android application and runs that in its own process. Uses this UID to set up the kernel level application sandbox. The kernel enforces security between the apps and system at the process level. through user and group IDs that are assigned to apps. By default, apps can interact with each other and have limited access to the operating system. Application signing. So this allows developers to identify the author of the application. It provides a more streamlined process to update the application. Every application that runs on the Android platform must be signed by the developer. Applications that attempt to install on a device without being signed will be rejected by Google Play. That's the official repository for Google Apps, or the package installer. Application signing is the first step to placing an application in the application sandbox. Signing defines the user ID that is associated with the application, and different applications run with different user IDs. So, let's talk about the importance of rooting a device. So, Android only allows a small subset of applications to run with root permissions. Android does not stop users or applications on modifying the operating system, kernel, or any other application. So if you have root, you have full access to the application and all application data on that device. Users that allow applications to run as root increase their threat exposure to malicious applications and application flaws. So now, I'm going to talk about components of an Android application: activities, services, content providers, and broadcast receivers. So an activity represents a single screen with a user interface. This is similar to a window in a desktop application, and an application can contain one or more activities. A service is a general purpose entry point for keeping an application running in the background. This does not use doesn't need a user interface, performs long running operations, or performs work remote processes. So for instance, examples, internet downloads and data processing. Then you have content providers, which supplies data from one application to others on request, centralized content in one place, and allows different applications to access it. So a common example of this would be like a database. Broadcast receivers responds to system-wide broadcast announcements. These messages are called events or intents. So an example of this will be when you've turned off the screen on your device, or if you have a low battery. So I want to talk about a APK tool for a second. So it's a tool that allows you to reverse engineer third-party apps, can decode resources close to original form. You can rebuild the application after modification. So for instance, you can decompile the application, make changes, and then recompile with your changes to see if it's there. So after decompiling the APK, you'll have the following folders: Smalley, Res, MetaInf, and the file Android manifest.xml. So for Smalley, you could think of this as assembly language used by the Android Dalvik virtual machine. It decompiles through a DEX file, and it's used for low-level inspection, of Android app content. So, I like to think of it as assembly. Most people don't look at the Smalley. Android is based on you build it with Java coded with Java, so most people would just look at the Java source code. But other people who are very ambitious, they might like to look at the Smalley to figure out the logic of the application. So, Res. This is a folder for additional files and static content. such as images, layout definitions, user interface strings, and animation strings. And the meta-inf folder contains the following files: the cert.rsa, cert.sf, and manifest.mf. So the first is assigned contents of the cert.sf file along with the certificate chain of the public key used to sign the contents. The cert.sf contains a list of all files along with a SHA-1 hash. And then the manifest contains information for the application, such as package version, build number, and creator of the package. With the Android manifest, this is located at the root of the project. Every Android application has an Android manifest file. And so this file declares components such as the package of application. It describes the components of the application, activities, services, broadcast receivers, and content providers. Declares permissions the applications must have in order to interact with protected APIs and other applications. And it declares the minimum level of the Android API that the application requires. So we have a sample Android manifest file when it comes up. So here, the manifest describes the package here, the minimum level of Android that needs to run on the app, the minimum level of Android for this application to run. In this case, it's number 2, so it's like the very first operating system of Android. Also, the activity is defined here. Okay. Have intents here, along with actions and categories. So to switch back to bug bounties for a second. So it's like, okay, I want to do bug bounties. I think I want to do Android. I found an app. I think I found a vulnerability. No, I found an, you want to do Android, and now it's like, I need to find a target. So how do I go about this? The reason why I specified Android is because, again, it's an open source platform, and it's a lower entry to barrier as opposed to the iOS. With the iOS, that code is proprietary and it belongs to Apple. So not saying that you cannot do bug bounties with iOSs, it's just a little harder. So you might be thinking, okay, why hunting? So there are multiple programs ranging from different sizes, from small to large. Sample programs you have are from the Department of Defense, Apple, and Facebook. And so when getting started with bug bounties, I tell people to focus on programs that are small. So, and the reason for that is because most people are going after the bigger, sexier platforms, and that's great, but you might get very frustrated because with those bigger platforms, you might not find vulnerabilities easier, or you might find something and someone already claimed it. So possibly more vulnerabilities to find, and then you can use the smaller bug bounty programs as practice to move on to the bigger, sexier programs. Okay, I jumped the slide. So now you found your target, and you're like, oh my God, I found a bug. Now I need to, claim it. So I would say reporting is probably the most important part of the bug bounty process. And the reason I say that is because there are a lot of people who found really sexy, vulnerabilities, but they didn't convey it in the proper way, and the company was like, not a bug. So, when composing your report, you should be thinking about business impact to the company. Meaning, okay, if an attacker was able to find this, what can they do? Can they, steal all of your data? What's the impact? Is it a loss of reputation? You need to think in the terms of the client, the business. And when you think of that, most times your report will be accepted. Also, if you find, you submit your really good report and you get a response and it's like, hey, it's a duplicate. Someone, found this before you did. Don't get discouraged. I mean, that just shows that you're on the right track. So, keep going. Someone just beat you first. When, doing bug bounties, make sure to save notes, whether it's in a notebook or a blog, because you'll realize with different platforms, different different companies, you might have encountered a similar bug, and if you don't have notes, you have to rely, on past memory. So it's good to have notes where it's like, oh, I found a bug similar to this. Let me see what I did and modify for that new bug program. So, how to get involved with bug bounties. Read write-ups if possible. Once again, with bug bounties, there is a thing called public disclosure and non-public disclosure. So what that means is, with public disclosure, the company's like, oh yeah, write a report, how you found this bug, right? And you'll find other companies that are like, well, no, don't release how you found this. We'll pay you, but don't publicly release how you found the bug. And take the plunge into bug bounties. Two really big and common programs, Bug Crowd and HackerOne. Also, there's tutorials. HackerOne has a CTF, and after you accumulate a certain number of points, I think the first is 26, then you start getting invited to actual bug bounty programs. So I think that's really cool. And then you have Bug Crowd University that teaches you different security vulnerabilities. Okay, so I have a quick demo. I have a quick demo of reverse engineering an Android application using the OWASP Mobile Security Testing Guide, the Uncrackable app. So here I'm using an Android emulator called Android x86. Most times if you're going to do Android reverse engineering with Android apps, you will really want to have the actual physical device. But for this demo, I'm using an emulator inside of a virtual machine. So here, so just to give a quick disclaimer, I did this demo like 30 times, trying to get it perfect. So I'm uninstalling the app because I realized I didn't do that when I first started. So I'm starting from A to Z. So that's why I'm uninstalling it here. So after this, I am going to go to the terminal and type ifconfig. So essentially, I need to get the IP address because I have another virtual machine that I need. I need my emulator in my virtual machine to talk. So I'm getting the IP address so I can use that inside my other virtual machine. So the 192.168.56.102. So this is my other virtual machine here, and I'm using ADB Android Debug Bridge. So, and I'm connecting to the Android emulator, so it connected successfully. Also, I'm using Frida, which is a dynamic analysis tool where you can change the logic in Android applications in real time. So we will be using that shortly. This will come on. So right now, I'm pushing the server to my emulator and starting as root, and then I'm already connected, but I just did that for a sanity check. And then going into the shell of my Android emulator, and I'm going to change the permissions for the Frida server, and then I'm going to start it. Now I'm putting the Uncrackable app on my Android emulator. So next, I will go and install it. So I set it to the download folder inside the emulator. And it's saying unknown apps, are you sure you want to install because you're opening yourself up to being more vulnerable? Yes. So installing the app, now I'm going to run it and root has been detected. This is unacceptable. The app is now going to exit. So it stopped us. So next what I'm going to do is show that yes, I am connected, the emulator is connected, and then I'm going to use Frida to look for the different processes and make sure that the Uncrackable app was hooked using Frida, which it was. Now I am opening JDX GUI, which is a decompiler for Android apps, and for this you can view source code. So that's what you're doing now. Well, you're viewing the source code for the app. So once again, this is written in Java. Just a quick note: when you decompile, you're not going to get the full Java code. What a lot of companies do is they use obfuscation. So the reason they do that is because they don't want it to where when you decompile their application, you have the keys to the kingdom and know how the application works. So what they'll do is they'll obfuscate the code and make it really hard for you to try to reverse engineer. You can reverse engineer obfuscated code. I know with Android Studio they have ProGuard, which is an obfuscation tool that you can use to de-obfuscate apps. So here we use Frida, and now we have bypassed that root has been detected. So, and I'm going to show the code in a little bit. So essentially we have bypassed that. So now we need to figure out what is the secret string. So going back to the application, we notice that there is a base 64 decode to the right, along with we're using a AES cipher. So next we need to figure out the string, and we're going to use this code here to get that. So next, I'm going to run Frida again to get the secret string. Now, for this to work, I need to go back to the app and type in anything. So at this point, I'm going to type in test. And it's going to say, nope, not yet, try again. Going back to the terminal, we have the passcode, which is I want to believe. So now, success, we entered the correct secret. So now, I'm going to show the actual code to make this possible. So with Frida, I'm using JavaScript, but with Frida, you can use Python and other languages. I just use JavaScript for this example. And so essentially what I did, and I know that's very, y'all probably can't read that. So sorry about that. So essentially what I did was simply override those methods and have them returning false. So essentially for the root privileges, that logic was returning true. That's why that dialog box came up and was like root detected. So I set those to false to bypass that, and then I also overrode the AES code. So created an array, and then essentially once typing in any text, basically changing it into the character equivalent and having the string be presented to us inside the terminal. So just showing basically overriding those methods. Okay, so the last little bit is just basically showing how to use the APK tool. The D is for decompile. So essentially, I'm going to decompile the uncrackable level 1 application, just showing just how how you will use the APK tool, and then showing some of the folders that I talked about, Smalley, Res, and the Android manifest.xml. And again, you really can't see that, but it's just the XML describing the intents and everything for the application. So summary, the attack vector for mobile apps and devices is wider. Barrier to entry is low with Android. You can decompile Android apps and look under the hood. Bug bounties are not a one-size-fits-all. Frida, is a good tool to use for dynamic analysis, as you can change logic on the fly. And there is no silver bullet application with mobile security. So, I created an intro to Android security VM. So it has 2 additional apps, the Insecure Bank and the Hacking Playground. I will add the Diva Insecure app in the next release. So to use it, push the apps to the emulator using Android Debug Bridge. Also, I'm working with TryHackMe, which is a online hacking company, to add the VMs to the site. But if you want to download the VM, you can go to SourceForge, and the URL is right here. And just resources and suggested reading, and that's it.